Hi, I'm Luc, ON7DQ, and behind the camera is Jill, ONL12523, who is the programmer of all the software that we will discover in a moment. We are both members of the OST Radio Club in Belgium. Our club is called OST for short, and we are proud to present you this project, the OST Morse box. What is the idea behind this Morse box? It's meant to connect to your transceiver, the regular VHF or UHF transceiver, and you can send CW in FM modulated tones and have some practice sessions with your club members. Inside is a printed circuit board that you can order, but you can also build this project in breadboard style. You can make it as easy or as complicated as you wish. Many things are optional. It's all described in a fine manual. We will talk about that later. Now let's have a quick overview of what you can see on the front panel, and after that we will look at the back side. On the front panel you'll see a number of switches, controls, a display, push buttons and a touch paddle. Let's see from left to right what we have. Of course, first we have the power switch. When we power up the Morse box, the display will show some information like the version of the software and so on. There is an LED when power is on, the LED is on. We have a switch for PTT. This means that you can put your transceiver into transmit, and everything you send will go on the air. But if you intend to do some local practice, you can switch off the PTT, and now we have only local tones and we are not transmitting over the air. Whatever you do, your microphone is still active. You can just grab your microphone and talk to people on the frequency, just like we did before. We'll see on the back in a moment how this is all done. The things to the right here are all concerning the decoders. We will talk about that later. Here you have a volume control, very conventional. Delay control, which is controlling how long your transmitter stays on the air after you stop keying. And this is the speed control, which sets the words per minute between 10 and 35 words per minute. In between you see two switches. You can push them down for once transmission. You can put them up for continuous transmission. The left one is used for random groups. So let's see if we can make a random group. After the group is sent, the text that was sent is shown on the display, so you can instantly correct your mistakes or see if you were correct. The beacon switch will send the beacon text, or you can program it with the CQ message like I have done here. Now this might take too long. Whenever you touch a key or paddle, the transmission is interrupted. In case you did this by accident and you didn't really intend to call CQ. On the top right we have a number of switches and controls and a push button that are all concerning the decoder that is built in. In my box there are even two decoders. We have two different versions. One is working on the PLL principle with an LM567 tone decoder. The other one is a bandpass filter which will filter the tones between 450 and 900 Hz and will then be followed by a level detector which will decode the CW. Whatever you choose with the switch here, you can switch PLL or bandpass filter decoder, and you can even switch an internal or an external signal which is fed to the decoder. Anything you receive will be shown on the display. Now, how do we see the difference between what you send and what you receive? Send text is shown in lowercase, the decoded text from the decoders is in uppercase. In case you don't want a decoder, you can switch it off with this push button. Now this push button is also used to switch on a local tone generator, which you can use for adjusting your decoder if you connect the output to the input on the back side, or you can just use it as a test tone. Another push will switch off this built-in generator. On the bottom right here you will see a touch paddle contact. These are just two pieces of PC board, and this makes up a touch keyer. Let me adjust the volume. So even that is built in. Of course, you can connect an external paddle, and we will see that on the back side. On the back panel we have a lot of connectors that you see here. All these are mounted on the printed circuit board. So you don't have to do any panel mounting, just make some holes or just make one large rectangle for all these connectors at once. Let's start with this one here. Here you connect your microphone. That can be the original microphone of your transceiver. In this case from a Kenwood rig with an RJ45 connector. This will be connected all the time to this connector. The connection to your transceiver is with like a short Ethernet cable or network cable, and you plug that in the transceiver output. So even when the box is not powered, you can just use your microphone to call CQ in FM on your transceiver. Let me disconnect these two to make the picture a bit clearer. Next to that one we have a key output. This is to key an old transceiver which does not have an electronic keyer, or you can use it to key a beacon transmitter or a QRP rig that you made. The output is isolated with an optocoupler, so it's safe to key any other rig. Then we have two inputs. One is for paddle, the other is for a straight key. You can also connect a bug or a QT key and this connector. Then we have a USB connector to the Arduino. This is if you want to use the Windows program to control the Morse box, or if you have to upgrade the firmware in the Arduino. The final connector here is the output for a speaker or for headphones. Just a note that the output is not attenuated for headphones, so you might want to add some resistors in series at the inside if you don't want to blow your ears out. Then there are some optional extras that I have added here. To the left here I have the external input for the signal for the decoder, which is controlled with the switch on the front. So this can be connected like to an HF receiver that you have, and you want to see if our box can decode the CW from the HF bands. There is an input for a 12 volt or let's say 13.8 volt power supply that you have in your shack, or another battery or whatever you want to power the box with. And then we have finally here very optional reset button for the Arduino. You can of course also power off and power on again. This will also reset the processor, so no problem there. Now the Morse box is not the only thing that we made. Jill has written a very fine program which runs under Windows. It might run under Linux if you use Wine, but we have not tested that. The program is also available on GitHub. It contains a lot of things here. You have a status bar, a send bar, a beacon text bar, you have some memories for a memory keyer, you have a serial monitor, and at the bottom you have a number of buttons to control everything. We will not show everything here. There is a video about this program which has much more detail. Just let me show you that you can adjust all the EEPROM settings of the Arduino, and you can set the tone frequency, you can invert the paddle working, you can switch on or off the decoder, set the words per minute. There is an internal iambic keyer where you can select the plain iambic mode or the mode A or mode B. You can set a beacon delay time, you can set a PTT time, and you can change the beacon text. All possible in a separate window. You can send a beacon with a button like this. Below that you have like 19 memories that you can fill. The button on the Morse box has only one of those memories, but you can add additional memories here, like sending a QRL on the frequency. All what you send and also what you receive, if you have the decoder option, will be displayed in the serial monitor, and you can even save this text to a file and load files. You can load the text file as a practice text, and you can send this text, let's say one line at a time. I will not send the other lines, but there are 3 more lines. If you want to send all of them, you can just press the start button and everything will be sent out. So we can switch on the generator or switch it off again. There are buttons to switch on and off the CW decoder and so on. Very fine program. We will explain more details in a separate video. All information for making this project is on a GitHub site. You will find the link for that below, where you find the manual with the step-by-step instruction, the instructions how to wire the box for your particular transceiver. You can find the Gerber files to make the PCB. You can do it locally or you can order it cheaply in China. So you have all the information available. We hope you like our project. This is the end of our short overview. Be sure to check out the longer videos which have more detail about every aspect of this project. 73.